Well, hello guys, here Mr. G with another video about electrochemistry for the grade 12. Yesterday or the previous video, we just learned about oxidation and reduction. Just a quick recall: oxidation is the loss of electrons by a molecule, atom or ion, and reduction is the gain of electron by molecule, atom or ion. We also learn about oxidation number and we follow the rules. We learn how to determine the oxidation number of some atoms or substances in which there were no in the rules, and we did the example of calculating or determine the oxidation number of sulfur in sulfuric acid. Guys, that was all. Then we define oxidation and reduction in terms of oxidation number. Remember, oxidation is when the oxidation number of an atom increases, and reduction is when the oxidation number of an atom or ion or molecule decreases. Now, what is a half reaction? This one is what we just taught. Half reaction is either the oxidation or reaction part on the redox reaction. Guys, is not so bad. Half reaction is the example we have here for the oxidation and reduction at the beginning. So we can, for instance, say that this one here is an oxidation half reaction. That is what happened to sodium, and this one here is the reduction half reaction. It's a half reaction because it's only the atom that is involved in either oxidation or the atom that is involved in reduction. So it's not that bad. That is what we call half reaction. We're going to go into more details now with one example so you understand what is half reaction. For now, you need to learn the definition is quite important. It's either the oxidation is either one of them, either oxidation or reduction. Reactions that are part of the redox reaction. Redox reaction is the oxidation reduction kind of reaction. So let's perhaps write down what is a redox reaction, and that one is a chemical reaction where electrons are transferred between atoms or molecules. Okay, in other words, is an oxidation reduction. If we go to the redox word and we break it into part, we have read, and that one is for redox or reduction. Let's not write redox, reduction. I'm writing the same word. Reduction, and then the C is out, and then the other part is for oxidation, and that is the important part here. So this word, if you go, this one is for oxidation. You can see that we break that word in part is reduction, oxidation, or oxidation, reduction. Okay, so now, what is another concept we must learn? The substance that is producing or causing the other one to be reduced is going to be called reducing agent. So reducing agent is the substance that causes another one to be reduced. In other words, it will be the oxidizing agent. So the substance that is being oxidized is going to be the reducing agent. I hope you write in the note there. The substance that is being oxidized is going to be reducing agent, because the agent is that substance that causes the other one to be oxidized, and the one that is being reduced, the substance that is being reduced, is going to be the oxidizing agent, because it's causing the other substance to be oxidized. Okay, so that's quite simple, and let's look at one example. This one is very, very simple, and then with this example will be the end of this video. Okay, this example says for the following chemical reaction, and you have this chemical reaction there, represent the oxidation number on each substance. Guys, what we're going to do here is to write the oxidation number of each of the substance right on top. Okay, so for zinc, remember the atoms or the molecules made of one atom is going to have an oxidation number of 0. So the oxidation number of zinc in this first part is 0. This second one here is an ion, is a monoatomic ion with a charge of positive. So the charge here is going to be positive 1. That is the oxidation number of hydrogen in that specific point. But zinc here, when you go to the second part with the product, is going to be a monatomic ion with a positive charge of positive 2. It's a positive 2. This one is the oxidation number for zinc at that point. And then hydrogen is it's a diatomic molecule. It's a molecule. Therefore, the oxidation number is also going to be 0. And guys, this one is question 1.1. You can see the oxidation numbers right there on top. Let me erase that one. And then that's it. It's quite simple. All you have to do is to follow the rule. You don't have to mention what rule you used, but be able to get the oxidation number of the different atoms. Question 1.2, identify the substance that is being oxidized and the substance that is being reduced. So we have to go to each of them individual, from reactants to product, and see what happened. So let's begin with zinc. Zinc, from reactants to product, we go there. Now what we have here, the oxidation number increases. The oxidation number increases. I'm going to write from 0 to positive 2. This is mathematics. You know, it is a bigger number, positive 2. Oxidation number increases. We go back to the definition. The oxidation occurs when the oxidation number of the atom increases. Reduction occurs when the oxidation number of an atom decreases. So in this case, decreases, and therefore zinc is being oxidized. So that is oxidation. So oxidation happens, it means zinc is being oxidized. I'm going to write here oxidation, and for us to make it clear, we say that oxidation has happened here, but zinc is being oxidized. So zinc is being oxidized. That was zinc. Now we're going to do the same with hydrogen. So let's come here to hydrogen in the reactant and hydrogen in the product. Those are the only two atoms here. Sometimes you have more atoms, and you have to do the same with every single atom that you have in the reaction. So you can see that the oxidation number decreases. Let me write it at the bottom here. Decreases from positive 1 to 0. You can see that decreases from positive 1 to 0. And in the definition, they say that reduction is when the oxidation number decreases. You can see it right there. I hope you are taking a note there. So hydrogen is being reduced. That is important. So hydrogen is being reduced, and reduction is taking place there. Guys, it's quite simple. I hope you are writing notes. It is important to write notes so you don't forget. Now, question 1.3, write down the oxidation half reaction and the reduction half reaction. And this is, I guess, very important because we didn't practice it. So let's write both half reactions here. Guys, all you have to do is to extract each of these pieces as we identify oxidation and reduction. So let's go to do here 1.3, okay, and let me go to a new page, perhaps 1.3 here. Let's clean and do here 1.3, which is the half reaction and the oxidation half reaction. Now we're going to zinc. Now what we have, reactants to product. So in the reactant we have zinc, Zn. Let's write the exact, it is the solid, and then in the product we have Zn plus 2 plus, and this one is aqueous solution. Okay, so now what we have to do here, we have to balance. Now, we always have to balance the equation, but we have to balance the number of atoms and we have to balance the charge. Okay, and this is the part where you can get confused. To balance the charge, we are going to add electrons. To balance the charge, we add electron in or to the most, let's write to the most positive side. Let's write the side to the most positive side. So we're going to balance this one. We have to balance the atoms as well as the electrons. And to balance the electrons or the charge, let's say we add electrons in the more positive side. Guys, let's see quickly here. Okay? And let's do it step by step. Remember, you don't do it like that. You don't have to. Let's go to the atoms first. We have here one zinc on the left hand side and we have zinc on the right hand side, so the number of atoms is balanced, it's done. Now the charge, if we go to the charge, we have a charge of 0 on the left hand side and we have a charge of positive 2 on the right hand side. So all we have to do is to add electrons to balance. Remember, the electrons are negative charge. So if we add 2 electrons here, 2 electrons, for example, then this one is minus 2. And you know, positive 2 minus 2 is 0, the charge is balanced. So the oxidation half reaction is Zn, solid, an arrow Zn, 2 plus aqueous plus 2 electrons. This one, guys, is the oxidation half reaction. This one is the oxidation half reaction. Oxidation half reaction. I hope you understand. Let's go to the reduction half reaction. Same story, and let's do it quite slow. We go to the equation and we take the substances or the atoms as they are there. The 2's at the front, the coefficients, we keep it there where they are in the equation. Is not part of this one. So we say H plus, we have here 1.3. We are for the reduction half reaction, we have H plus on the left hand side. It was, let me see, aqueous. And on the right hand side we have H2 gas. There we go. Here we have H2 gas. Guys, here is what we have, and we have to balance. We have to balance like it said there. So we first going to balance the atoms. On the left hand side you have one hydrogen atom, ion, but it's the same, and on the right hand side we have 2. So we are going to fix this one by write 2 at the front of the H. Now it is balanced. Second, we are going to balance the charge. So let's make sure we don't make mistake with the charge. On the left hand side we have a positive, but we have 2, so it's 2 positive. Okay, and on the right hand side we have a 0. So how do we balance here? Remember, we add electron to the most positive side. So we're going to add electrons on the left hand side. So what we have? 2 hydrogen. How can we balance the electron? If we add 2 electrons, guys, 2 minus 2 is going to be 0. The electrons are always negative. So let's say plus minus 2 electrons. Maybe you get confused. So what we have here, 2H plus aqueous plus 2 electrons will give you H2 gas. And guys, this one is the reduction half reaction. This one is reduction half reaction. There we go, and we are done. This one is how to write the half reaction for oxidation and half reaction for reduction. And to finalize, identify the reducing agent and the oxidizing agent. Quite simple. Whatever is being oxidized, which is in this case the zinc is being oxidized, therefore is going to be the reducing agent. zinc is the reducing agent because it's been oxidized. What is that? It's because it is the one responsible for hydrogen to be reduced. That is why it's the reducing agent. Okay, so zinc is the reducing agent, and the oxidizing agent is the substance that is being reduced, which in this case is hydrogen. Hydrogen is being reduced, therefore hydrogen is, I'm going to write it at the bottom here if you're following me, this one is the oxidizing agent. That is the oxidizing agent. And guys, this one is all for now. So this one is the video. This is important video. This the first two videos of this electrochemistry are related to grade 11 knowledge, but without that knowledge you will not understand and you will be unable to do the electrochemistry for grade 12. So I hope it helped. If it helped, thumb up, subscribe for the channel. I'll see you next time. Next time we're going now to the first type of cell, okay, down to grade 12 content. But thank you for watching. Mr. G here.